go, here we go, here we go. Oh my God, it's so exciting. Day one, after school review. Logs and exponential equations. Doesn't get it any more exciting than this. Anyway, I hope you love logs as much as I do. Just kidding. They're not that bad. As long as you have Mr. Key to help you out. Oh God, my jokes never get old. All right, so let's just get rolling. Let's just rock and rolling. The best thing you can do is just keep practicing problems. Keep on practicing. Keep on practicing. All right, here we go. We got log base 4 of x equals 2. Now, if we have a logarithmic equation, we need to turn it into an exponential equation. In order for it to be an exponential equation, and here it comes. It's all about that bass, all about that bass. I have no idea who sings that song, but I'm pretty sure I nailed it. Okay, the base is this thing. Here's our logarithmic base. It's all about that base. So what we're going to do is copy over that base 4, and then these two things are simply going to switch sides. Log base. Now notice when I change it from a log, it becomes an exponential equation. You don't see the word log there anymore, do you? Oh, no, you don't. So 4 squared equals x, or x equals 16. Done. All right, here we go. Ready? It's all about that base, So 2, and then switch. 2 to the 4th equals 5x. Let's see, 2 to the 4th. 2, 4, 8, 16. Okay, 16 is equal to 5x. X is equal to 16 over 5. Leave it. That's a 5. Yeah, it's a 5. So when the base is non-existent, like there's nothing here, you don't see it. Like, where'd my base go? Where's the base? It's a base 10. So we'll do 10 to the 1 equals x plus 6. These two things just switch sides. These are really fat pens. So I get x equals 4. I would check these, except for my graphing calculator is no longer working. I have to figure that one out. Anyway, it's all about that base, By the way, you should be pausing these now. Pause them. You got it. You know what you're doing. When you get to a problem you don't know what you're doing with. By the way, these problems can be downloaded at www.mrkrausmath.com. So look for Regents Review or something like that. I haven't updated my website to make sure that after school review. You'll probably be under Regents Review. Look for after school review, and you'll be able to download all of my review documents and my review files, and with links to all the videos. So it'll be nice. I haven't updated it yet, but it will be soon. Probably by the time you look at it, it'll be there. Oh, what happened? Come on. So it's all about that base. Man, you're going to get tired of me singing that. I'm already tired of listening to myself sing it. So I do 3 squared equals 3 squared. So that thing's got to go over there. That thing came over here. So 3x minus 1. So 9 is equal to 3x minus 1. 10 is equal to 3x. X is equal to 10 over 3. Does it get more difficult? Oh, yeah. You remember it does. All right, so when you have two things that are equal to each other, let's say I got rid of this. Well, let's say I have this. Wait, hold on. Let's say I had this. Log of 4 of x equals log of 4 of 5. Wouldn't you just say, oh, well, this thing here just has to be a 5, right? Because then they would be exactly the same thing on the left and the right. Well, that's exactly what we have here. We just have it in a little bit more difficult format. Take a look. What I have is log base 4 of this equals log base 4 of 8. Well, doesn't it then just kind of go to function that these two things, or go to, I don't know what I'm talking about. Those things have to be equal to each other, don't they? I mean, it would make sense that those things have to just be equal to each other. So I just got to get x plus 2 equals 8. Or x equals 6. That's it. I'll be right back. All right, I think I got a pen that's smaller, so that's kind of what I want to do. I got a pen that's smaller, not so thick. All right, here we go. So again, we've got this equal to this. The logs are the same. The bases are the same, so we'll bust it out. And all we got to do is basically say that 2x has to equal 3. Whoa, 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 whoa. Let's back up the crazy train. 2x plus 3 has to equal 3, or 2x has to equal 0, or x just equals 0. Well, doesn't that make sense if this is gone? I have log base 5 of 3 equals log base 5 of 3. That's kind of simple. That's not bad. All right. Whoa, whoa, what is that? Whoa, whoa. Okay, you got to remember one of the laws of properties. When you have numbers in the front, such as this 1/2 or this 2, where those came from. And if you remember correctly, they came from, I thought I got a skinnier pen. Maybe this will work. All right. They came from being here, and this came from, much better. This came from being here. So, if you remember, I should have put it like right here. What they are is exponents. Properties of logarithms say if you have an exponent, it should go in the front. So this is really, when you have a number in the front, it's really just becomes an exponent. So it's x to the 1/2 is equal to 2 squared. Now, you have to remember, what does 1/2 as an exponent mean? Oh yeah, that's right. It means square root. So the square root of x is equal to 4. Or x is equal to, what happened there? 2. That's like a triple equals. That doesn't make any sense. We'll get rid of that. Equals 2. Briscoe. Go upstairs. Go upstairs. Good boy. No, leave it. Crazy dog. He just wants to be with his daddy. Uh-oh, this one's going to be tricky. Go upstairs. So, we're going to return that. So this is x to the negative 2 equals 9. Let's see, x to the negative 2. X to the negative, I know x to the 2 is x squared. Oh yeah, negative exponents. That's really a fraction. This is really 1 over x squared is equal to 9 over 1. Well, now I might want to just cross multiply. So I get 9x squared equals 1. Just cross multiply. Or x squared is equal to 9. So I get x squared is equal to 1/9. I come in. I take the square root of both sides. I remember when I take the square root of both sides, I put a plus or minus. So I get x is equal to plus or minus. The square root of 1 is 1. The square root of 9 is 3. Now here's a problem, and I don't have my graphing calculator to show you. You can't take the log of a negative number. If you remember correctly, the graph of a logarithm goes to the point 1, 0, and it's asymptotic to the to the y-axis. So it kind of looks like this, right? A general logarithmic equation looks like this, which means the value of the domain of a log function is x is greater than 0, which means you can't take the log of a negative number. Therefore, my only answer to this one is positive 1/3. So the answer to this one is 1/3. All right. Now we're going to get into some of the more tricky stuff. Like really tricky stuff. This isn't bad, I think. So we're going to return this 3. That becomes a cube there. And that's gone. but I still have two logarithms. And you're not allowed to solve an equation that has two logs. There's no way to do anything with two logs unless you condense them. So the first thing we're going to do after we return exponents is condense logs. I don't know if I spelled that wrong. Might have. So you have to remember that when you have addition and you're dealing with logarithms, that really comes back to being multiplication. So this is really x minus 1 cubed. Why is this a cube? Wow. Cube times 4 is equal to 5. Log base 2 of that. So I condensed them into one logarithm. So now what I got is I got 2 to the 5th is equal to 4 times x minus 1 cubed. I think this is going to work out. I think it's going to work out. So let me do this. Let me finish this problem up. This is 32 is equal to 4 times x minus 1 cubed. If I divide by 4, I get 8 equals x minus 1 cubed. Now, if I take the cube root of this, not the square root, but the cube root, and I take the cube root of this, I get x minus 1 equals 2, or x is equal to 3. Tricky problem, but not bad. This one's a little bit more, this is a little bit more manageable. So the first thing we're going to do is return the exponent squared. Now I've got to condense these two logs into one log. Log base 3. When you have subtraction, if you remember correctly, that comes back to being division. So x plus 4 squared over 9 equals 2. So now it's all about that base, Get a new number, get a new pen out there. So I get 3 squared. These switch, right? This goes over there, this comes back over here, equals x plus 4 squared over 9. Well, this is really just 9. We'll just cross multiply. 9 times 9 is 81 is equal to x plus 4 squared. At this point, I would just take the square root of both sides. Take the square root of this side. Oops, too big. I'm trying to get these all to be nice, thinner pens. I thought they all did change. And I'll take this square root of this side. But when you take the square root of this side, you got to put a plus or minus. So I get 9 is equal to x plus 4, plus or minus 9. Subtract 4, subtract 4. So I get x is equal to negative 4 plus or minus 9. So x is equal to negative 13, or x is equal to 5. But again, we got to go back up and see if one of these is going to cause a problem. If I put a negative 13 in here, this would give me something negative that I cannot take the log of. So that answer's just got to go away. Tough problem anyway. All right, there it is. The answer is x equals 5. Keep moving, kids. Keep moving. Pause it. Come back. Now remember, when the base is non-existent, there's really a 10 there. So what we're going to do is we're going to condense these. So we'll make it log. And I'm going to put that 10 in there just so I remember it's there. And we got multiplication, or we got addition. So when I condense them, it becomes multiplication. So x times x plus 15 equals 2. And now you sing, it's all about that base, So I get 10, and then these two things switch. Squared is equal to x times x plus 15. Well, now we got some work to do. We got 100 is equal to x squared plus 15x. Bring the 100 over. I get 0 is equal to x squared plus 15x minus 100. Multiply to 100, add up to 15. All right, kid, it's not that difficult. Plus 20 and minus 5. There's not that many ways. So I get x equals 20, which is negative 20, which is probably going to be a problem, but we'll have to take a look at it. And x equals positive 5 should be okay. So I come back up here and I say, if I plug a negative 20 in, oh, look right here. If I plug a negative 20 in here, immediately I'm taking the log of a negative number. You know that's not possible, so gotta go. All right. So hopefully this next one, I get a number bigger than 21, because any number that's less than 21, probably not going to work. All right, because I can't, if this number is 20 right here, that would give me negative. If it gives me 21, it's 0, and you can't even take the log of 0. It's got to be bigger than 0. So our answer here better be bigger than 21. All right, so we're going to condense log base 10 of x times x minus 21 equals 2. Now we convert 10 squared, these switch, it's all about that base, is equal to x times x minus 21. Are you already getting the factoring done in your head? This is 100. Some of you are like, what? X squared minus 21x. Bring the 100 over, so you get 0 is equal to x squared minus 21x minus 100. Excuse me. X. All right. Not that bad, kids. Minus 25 plus 4. So my two answers become x equals 25 and x equals negative 4. All right. We know our number's got to be bigger than 21, so this one would cause problems. All right. I'll be back. So eventually I'm going to figure out how to get these pens right, but not yet. Oh, come on, move over. Why can't I get that to move over? Let's do it this way. We'll do it the old-fashioned way. All right. So I'm going to condense these logarithms. They have a subtraction. Subtraction condenses to division. So it's log. You don't see a base, so it's base 10. Notice I put the base down here at the bottom of the G so it doesn't get confused with the work that I'm doing over here, is 2x over x minus 3. Leave everything in parentheses. Equals 1. These pens are so fat. How do I get them to be thin? So, it's all about that base. So 10 to the 1 is equal to 2x over x minus 3. All right, so now I have a simple fraction ratio proportion set up, so I'll just cross multiply. 10 to the 1, by the way, is just 10. So this becomes 10x minus 30. I'm just going to distribute it to both those. Equals 2x. I don't like having my x's negative, so I'm going to bring this over here by subtracting it, so I get 8x. But that means I got to bring the 30 over there, equals 30, or x equals 30 over 8. All right, if you prefer 15 over 4, that's fine. What's that word? Yes, it's the natural log. The natural log. All right, so we're still going to condense these to one log. It's just the natural log of x plus 1 over x equals 2. Now, this one you just have to remember that the base is e. Still all about that base. So it's e That's this. What is that thing? It's e squared is equal to x plus 1 over x. Why did I do this problem? I'm going to skip this one only because I don't have a calculator to show you how this one's finished, and that would be, it's kind of a royal pain in the neck without a calculator. So let's just skip that one. We'll come back to it. Hopefully there's be an easier E one that I can do without that. But unfortunately, without the calculator to show you, it's just useless. So let's just keep going. All right. I wish these would permanently go to thin. We're going to condense these two logs, and we're going to make it log base 2 of, let's see, multiplication, because it's addition. It reverts back to multiplication. Now it's all about that base. So it's 2 to the 1 is equal to, now I'm just going to double this. I know I can put this right here, but I'm going to double distribute it out. So I get x squared plus 15x plus 56. I hope you know how to double distribute or FOIL. I don't know, whatever your teacher uses. Used to frown on double distribute. So 0 is equal to x squared plus 15x plus 54. So is there a way to multiply to 54 that adds up to 15? Now they both got to be positive. Come on, kids. 6 and 9. So your two answers are x equals -6, which could be a problem, and x equals -9, which could be a problem. We got to go back up and look. Do either of those cause my original problems to be negative? Both of these are negative. So if I plug in -6 here, -6 here, that's positive. And if I plug in -6 here, that's positive. So that's okay. But if I plug in -9 in either one of these, they become negative. And that's a problem. So we got to get rid of this. So -6 is our only solution to the problem. 16. Here we go. Got to condense. So we're going to take this addition and we're going to condense it to multiplication. So I'm going to do log base 2 of x times x minus 2 equals 3. Now it's all about that base. Oh my gosh. I should have been a singer. I could have made millions. So we're going to do 2 cubed, which of course everybody knows is 8, is equal to x squared minus 2x. Just distributed that. I'm going to bring the 8 over, so I get 0 is equal to x squared minus 2x minus 8. Come on, you guys know this is an 8. 2 times 2 is 4 times 2 is 8, not 6, kiddies. So 0 is equal to x minus 4. X plus 2, my two answers are x equals positive 4, which shouldn't be a problem. X equals -2, which might be a problem. Let's come back up. Yep, right there. If I plug in -2, that gives me -4. If I plug in -2, that gives me -2. That's a problem. Got to get rid of you. So there's my answer. 4. Holy mackerel, that one looks so scary. We'll come back to it. All right, let's condense, because we like to condense. We're the condensers. We're the condensing people. So we'll condense. So it's log base 6 of those two things multiplied, x plus 4 times x plus 3 equals 1. Oh my God, these are the easiest problems to write, these ones. So it's all about, you got it, the base. It's all about that base, all about that base. By the way, hate that song. 6 to the 1 is equal to, now I'm going to put this on the other side. I'm going to double distribute it now. X squared plus 7x plus 12. If you can't double distribute, it's time to learn. Subtract 6, I get 0 is equal to x squared plus 7x plus 6. 0 is equal to, now we factor, x and x plus 1 and plus 6. Uh-oh. Going to have two negative answers again. So this one gives me x equals negative 1. So I got to really check that one. And this one gives me x equals negative 6. I got to really check that one. See if either of these causes a problem. If I come back up here and I put a negative 6 in here or a negative 6 in here, both of those would turn those negative. So you cannot be a solution. So my answer is 1. All right. Whoa, what do we got here? We still have to condense these logs, but they're not on the same side. So the first thing I'm going to do is get them put together. So log base 8 of x plus 6 plus log base 8 of x plus 4 equals 1. Just brought this thing over here. Then, let's see what this pen size is. Then I'm going to condense them. So log base 8, that's too fat, of, now these are this is addition, so it goes to multiplication, x plus 6 times x plus 4 equals 1. All right, now it's all about that base. 8 to the 1 is equal to, and I'm just going to double distribute this stuff because I can do that, x squared plus 10x plus 24. Bring the 8 over. I get 0 equals x squared plus 10x plus 16. Got to find a way to multiply to 16. That adds up to 10. X and x plus 8 plus 2. Again, I've got two negative answers, so I'm going to be careful. Oh, I'm not done yet. I got x equals negative 8, which is probably the one that's going to be the problem, and x equals negative 2. But they might both be. Let's see, if I plug a negative 2 in here, that's okay, but I plug a negative 8, that crashes. Negative 2 is okay, so 8 crashes. Gone. Negative 2. Man, terrible. So this next one's a little funky. First thing I'm going to do on this baby, woo, man, that's like an hour-long question right there. Look at it. It goes forever and ever and ever and ever. All right, first thing we're going to do is condense them. Remember, the base is 10, but I'm going to put that in there. Log base 10 of x minus 1 divided by x plus 6, because it's subtraction, right, equals log base 10 of x minus 2 over x plus 3. Now, it's not looking too bad right now. I think I can handle this. Look, if this thing here matches this thing here, let's say they were both a big 5. Let's say they were both 5s. Well, they'd be equal to each other. So really, the only thing I got to do is say, hey, when does this equal that thing? I mean, that's all I got to solve. Oh, yeah, then it's not even a log question anymore. It's x minus 1 over x plus 6. When do you equal x minus 2 over x plus 3? So that's actually the problem I have to solve right there. So we're going to cross multiply. I'm going to try to save myself a little bit of time here. These two I'm going to multiply. I'm going to do the double distributing right away. X squared plus 2x minus 3 equals, and I'll double distribute these, x squared plus 4x minus 12. Well, these cancel. And I don't like having a negative x squared. Or I don't like having a negative x. So I'm going to subtract this 2x. Subtract this 2x. So I get 2x equals, and then I'll add this 12. Add this 12. And I get 2x equals 9, or x equals 9 over 2. There's my answer, kids. Not bad. Oh, I'm going to pause. I'll be back. Yeah, the reason I have to pause every once in a while is sometimes the video and audio get out of sync. And the more frequent that I just stop and take short snippets of video, the less problems I have. So that's why, just in case you were wondering. Okay, let's get started. We're going to condense these. I have subtraction here. I know subtraction by now condenses to division. And I have a base of 10. I like putting that base in. Even though I know I don't have to put it in there, it just reminds me that it's there. Equals 3. Now it's all about that base. So 10 cubed is equal to x plus 3 times x minus 3 over x plus 3. Now, where the heck did I get that from? Well, that is really that. Remember, if I factor, it's just the difference of perfect squares. So if I factor this, it really just ends up being that. Oh, well, why'd you do that? Oh, so I could do this. So now I've got 1,000, which is 10 cubed, is equal to x minus 3, or x equals 1,003. Ka-ching! Don't you wish you were a math teacher and this stuff came so easy for you? And you're like, but how would I know to do that? You wouldn't until you practice and practice and practice. And then you just play with it. And if you don't get it the first time, you play with it some more. And just follow the rules of logarithms. There's not that many. We're going to talk about them at the end with our graph. So I thought that we're done. Oh, now we're going to do some reverse problems now. Oh, wait. I don't know if I wanted to start with that problem. I don't have a calculator for the e's. All right, let's just get working on these. I won't be able to give you the official answer. Well, maybe that's stupid. I don't think it will. Anyway, all right, let's get started. In order to solve problems like these, now we've got bases, right? I can do these two ways. I'm going to show you both ways, just in case you're wondering. I'm going to show you both ways. The first way I'm going to show you is to convert this to 2 cubed. Well, if that's 2 cubed and this is 2 to x minus 5, then don't those things have to be equal to each other? Yeah, I believe they do. So I'm just going to do it this way. So I get x minus 5 is equal to 3, or x equals 8. That's it. We'll just do it that way, especially on these easier problems. All right, so this is 5 to the negative x is equal to 5 squared. So doesn't that mean that negative x has to equal negative 2? Or in other words, x has to equal, I'm already going to the answer. Negative x has to equal 2. These two things just have to be equal to each other. Well, that's true. If negative x has to equal positive 2, then x has to equal negative 2. Negative 2. But, all right, I hope the calculator I find is useful enough for this. Let's see, do I even have one? I didn't find one in it. I don't know if this calculator is that great. We'll see. So, now I have a variable that's an exponent, and I don't have something that's nice over here. So when my variable is an exponent, I don't have anything nice over here. I have an exponential function, and the only way to solve an exponential function is to turn it into a log function. It's still all about that base. Here's the base. So what I'm going to do is turn this into a logarithmic equation. So log base 8 of, now these two things switch, 1.2 equals negative x. Well, then I just divide by negative 1, divide by negative 1, and I get x equals that. I don't know how to put that in this calculator. So irritated. Hold on, let me pause for a second. Well, I just downloaded the trial version of this software, and I get 30 days for free, so that's good. But I don't really see the calculator. There it is. So maybe this will work. Let's see. This is the TI Inspire calculator. This is the one we use in class. Goodness, go away. All right, so there we go. So what do I got to put in my calculator? I got to put this in my calculator. So it's control log base 8, right, of 1.2 equals, and then divide by -1 is just a negative that. So x is equal to negative 0.0, x is equal to negative 0.087678. 87678. Ka-ching. All right, so it's all about that base. So we're going to do log base 2, and then these two switch. So it's 1.5 equals negative x again. Divide by -1, divide by -1. So now I'm going to do control log base 2 of 1.5. And then I'll end up dividing by -1 if you want the right answer. There it is. Negative 0.5849. X equals negative 0.5849. The last one, 63. So in order to solve this one, the first thing you got to do is get this weird thing alone. You got to get rid of this 5. We're going to divide by this 5 first. So now what I have is 2 to the 3x equals 8/5. Now you have to do that because you can't convert it into a logarithm or transform it into a logarithm until you've done that. All right, so now it's all about that base. So log base 2, now these two things are going to switch, of 8/5 is equal to 3x. And then we'll just divide by 3. So I get x equals, so log base 2 of 8/5 divided by 3. So I get 0.2260. You know, it's like, well, who the heck knows if that's right? So what you could do is take this thing. By the way, let me just check something. Oh, it's not exactly the right answer. I thought it was rounding early. Like they're off by a couple of decimals. Like they should tell you around. That's actually the right answer. I'll store that into x. Control var. Use control var. That's control here and var here x. And then what I could do is say, okay, now this is my x value. It's close. I'm going to type the original problem in. The original problem was 5 parentheses 2 raised to the 3x. Now this should be close to 8. There it is, 8. So it's a way to check to see that you got the right answer. Because sometimes it's really difficult to tell. So first thing we're going to do is get the weird thing alone. I'll divide by 0.3, divide by 0.3. Gone. I get 4 to the 0.2x equals 0.2 over 0.3. Now, that's really just 2/3. But may not like that. So it's log base 4 of 2/3. If you don't like the fact that it's 0.2 and 0.3 and put 0.2 and 0.3, but it's really just 2/3, is equal to 0.2x. Divide by 0.2. Divide by 0.2. So I get log base 4. Good thing I found this calculator. Control log base 4 of 2 divided by 3 divided by 0.2. And I get -1 so I get x equals -1.4624. That's good enough for now. 624. Normally on the Regents, you want to give 6 decimal places at a minimum. Usually if it doesn't tell you to round, you don't round. You can always check that. I mean, again, it seems really weird that that would be the answer. So we'll take that answer and we'll store it into x. Oops, I forgot. Didn't like that I didn't press x. Enter. And then I'll type in 0.3 parentheses, so 0.3 parentheses, 0.4 raised to the 0.2x, and hopefully this is our answer, 0.2. There it is, 0.2. Okay, I'm done checking. You're just gonna have to believe me now. We can do e's now. So I gotta get the weird thing alone. This is the weird thing right here. Let me highlight it for you. This is the weird thing. I gotta get that thing all by itself. So we'll get that weird thing by itself. We'll go 3e to the x equals 2, subtract 7. And then I'll divide by 3, so I get e to the x is equal to 2/3. Now, if you're dealing with e, when you're working with e, you don't use logarithms, you use natural logarithms. So there are not logarithms, but you have to use ln. So if you want to write it like this, you can write it like this. ln of base e, and then these two things switch, of 2/3 is equal to x. So when you go to your calculator, what you're going to find out is when I do ln, it doesn't give me an opportunity to put e in, and that's because e has to be the base. Like in all other logarithms, it could be log base 2, log base 3, log base 4, log base 5, but with e or with natural logs, the base has to be e. So they don't even bother giving an opportunity to put it in. And then we're going to do 2/3 divided by 2 divided by 3. Somehow I didn't like my 2. 2 divided by 3. That's it. Enter. And I get that crazy answer. So x is equal to negative point. We'll give 6 decimals. 405,465. 405,465. Now, again, we can check this. I'll do one more check. Stow this into x. And then I'll type in 3e to the x. So 3e. Now notice e, not this e down here, but that e to the x. Get out of exponent mode, plus 7. And we're hoping this is 9. Perfect. All right. Great way to check. If you can check your answers, please do so. It's in your best interest. All right, we got some more e's. Let's do a few more e's. So, convert it to a logarithm, in this case, a natural log, a base e. Now, do you have to put this e here? You don't, because it's understood. But sometimes it helps, because you got 3 things here, and you want to know where those 3 things go. Sometimes it helps just to put the e there. Can't be taking points away for that. It is base e. You just don't have to put it there. Much like if I write the word x, you know that there's a 1 there. I don't have to write it. All right, so those switch. So natural log base e of 4 is equal to 2x. I divide by 2, and I get x equals. So we're going to do the natural log of 4. Get out of those, divided by 2. And I get 0.693147. 0.693147. I was just thinking I should show you guys how to get the graphing calculator. I'm going to put a link either in the show notes or maybe in the video somewhere if I remember. If I don't remember, email me, kenkraus@gmail.com, and I will email you and tell you how to get the graphing calculator for a 30-day trial. At least it will help you for the final exam. Got to get the weird thing alone, so we're going to divide by 4, and I get e to the 3x, that's an e, to the now it looks like an L. Maybe I should write an e better. E to the 3x equals 1/4. Now it's all about that base. So we're going to turn in a natural log. Base e of 1/4 is equal to 3x. Yes, that's a 3. Don't give me a hard time. Divide by 3. Divide by 3. So get off. Go away. All right. I forgot what we were doing. So natural log of a 4th, so control natural log 0.25, that's a 4th, except of course I didn't put anything. Divided by 3 is negative 462,098. X equals negative 462,098. Ka-ching. Whoa. Is that a fraction? Because I don't do fractions. Of course I do. Big wimps. So let's get rid of the 8 first. So we'll do 3/4 e to the 3x equals 2. It's amazing how much you guys hate fractions. To get rid of this fraction, we just multiply by the reciprocal, 4/3. 4/3. Whoosh, whoosh. So I get e to the 3x equals 8/3. So what? Natural log of e of 8/3 equals 3x. We'll just divide by 3, divide by 3, and I get, let's see, the natural log of 8 divided by 3, enter, forgot the 8, I didn't forget it, it just didn't like me. 8 divided by 3, divided by 3. 0.326943. 0.326943. Oh, good, we're done with those. Oh, now it's going to get interesting. Okay, so our exponents are variables. Whenever our exponents are variables, we want to use logs, except in this case, that would be really impossible because I'd have log base 32 and log base 16. That doesn't make any sense. So when the bases aren't the same like this, what we're going to do is try to make them the same. So again, and when I'm doing these kind of problems, you want to make the bases the same. And the bases you're going to either use are 2, 3, or 5. If it's even, use this one. If it's odd, use this one. And if it has a 5 in it, use 5. Like 25, 75, 125, 625, 3125, 6025. If it's got a 5 in it, use a 5. So 32 is even. We're going to use that as 2. So this becomes 2 to the 2, 4, 8, 16, 32. 2 to the 5th. So 2 to the 5th times 3/4 minus x is equal to 2 to the 4th times 5 minus 3x. I do not remember doing this problem. This looks like a real pain in the neck. So let's get through it then. So now that the bases are the same, I don't need them anymore, so I'm going to get rid of them and set the exponents. Really all I got to do is set the exponents equal each other. So 5 times 3/4 minus x equals 4 times 5 minus 3x. This 3/4 is still going to cause us a problem. So this is 15/4 minus 5x equals 20 minus 3 minus 12x. This exponent is a problem. This fraction is a problem. So what we're going to do is get rid of it right now. We're going to multiply everything through by 4 just to get rid of that stupid fraction. So these 4's cancel. That's why we do it. And I end up with 15 minus 20x equals 80 minus, oh, this should be x here. 4 times 12, 48x. Let's see, I don't want, so I'm going to bring this over here. I'm going to add 48x. So I get 28x equals, and I'm going to subtract 15. I get 65. So x is equal to 65 over 28. I'm relatively certain that's wrong. Got to be wrong, right? 65 divided by 28. We'll store this into x. Just seems wrong to me. And we'll go back to the original problem. The original problem was 32 raised to the 3 divided by 4x. Nope. 3 divided by 4 minus x. Whew. That's dumb. 16 raised to the 5 minus 3x. 5 minus 3x. Oh. mean I get the exact same answers here? That and that match? And that match? Oh, then I am right. Even though it's a ridiculous answer. Sure, no problem. Oh my goodness, look at that. We got another exponent that's a fraction. So first thing we're going to do is convert both of these to 2's. Yes, you can do 4's, but I like just saying everything goes to 2. So this is 2 to the 4th times x minus 3/4 equals 2 squared 3x minus 5. This 2 squared is 4. 2 to the 4th is 16. Now I just have to set their exponents equal to each other. So actually that worked out well for me. So if I'm just going to distribute a little bit on the way. So I'm going to distribute this 4. So that's 4x minus 3. 4 times 3/4 is 3. Is equal to 6x minus 10. Subtract the 4x, I get 2x equals 7, adding 10. And I get 7 over 2 equals x. And again, you can check this stuff. Take your calculator out, go 7 divided by 2, control var x, enter. And then type it in, 16 raised to the x minus, I'm just going to put 0.75. It's the same as 3/4. And then 4 raised to the 3x minus 5. 2048, 2048, done. Not going to check anymore. Yes, I think I have to. All right, again, I'm going to convert this to 2 to the 4th times x equals 2 squared times x plus 1. Oh, they're going to get harder. So this becomes 4x equals 2x plus 1. Subtract 2x, I get 2x equals 1. Divide by 2, I get x equals a half. One more. All right, they're odd, so I'm going to change it to 3. So this becomes 3 squared times x is equal to 3 to the x plus 1. All right, just set the exponents equal to each other now. 2x equals x plus 1. Subtract x, and I get x equals 1. They're even, so I'm going to convert them both to 2's. So this becomes 2 cubed, 2x, equals 2 squared times 6. Or 6x equals 12, or x equals 2. All right, I'll be back. Holy mackerel, this is already an hour-long video. All right, it's going to start getting more tricky now. I'm going to start doing some more difficult questions. So, let's convert. First we're going to do is convert these to 2. So 2 to the 4th, 2x plus 3, is equal to 2 to the, this is 6. 2, 4, 8, 16, 32, 64. 2 to the 6, x plus 2. And now it's just 8x plus 12. That new exponent is equal to 6x plus 12. Uh-oh. So I get 2x equals 0, or x equals 0. That's weird. So if that's 0, that goes away, and that goes away. So 16 cubed equals 64 squared. Let's see if that's right. 16 cubed, 64 squared. Oh, 4096. Beautiful. Uh-oh, SpaghettiOs. Got to do the same thing. Oops, this is a 6. So we're going to leave this as 6 to the x plus 1 because I can't make it a 2. Now this is interesting. 36 is 6 squared. Do you agree? I mean, if I just had that, that would be 6 squared, correct? Yes. But it's in the denominator. So what does that mean? Oh yeah, I know. If I have something that's a fraction, then I must be a negative exponent. So this is really equal to 6 to the negative 2. Oh. I just solve it like I did before. Set the exponents equal to each other. X plus 1 equals negative 2, or x equals negative 3. And you're going to do that with every one of them that's a fraction. So this one I can make into a 2 because it's an 8. So I'm going to make this 2 cubed x plus 2 is equal to, now 64 is 2 to the 6th. But because it's a fraction, I'm going to make it negative 6. So this is really 2 to the negative 6 times x. So now I just set the exponents equal to each other. 3x plus 6 equals negative 6x. All right, I'm going to bring this over here to make this 9x equals negative 6, or x equals negative 6 over 9. I brought that over to that side, and I brought that over to that side. I think that's the end of that page. This is the class that never ends. So this is negative 2 raised to the x is equal to, now this one's going to be interesting. How do I do this one? 128 is 2 to the 7th. So this looks like it's negative 2 to the 7th. To the negative 7, because it's in a fraction. So x looks like it equals negative 7. That's weird. Let's see if that works. Got to be careful, though, because this one's in parentheses and this one's not in parentheses. So let's go back. Let's take negative 7 and stow it into x. And I get negative 7. So negative 2. Oops, we got to put it in exactly the way they got it. Parentheses, negative 2, parentheses, raised to the negatives, raised to the x. Isn't that exactly what I have? And it's equal to negative 1 over 28. Boom, done. Over. So same problem. So negative 2 to the x is equal to negative 2, 2, 4, 8, 16, 32, 64, 128, 256. So it looks like x is equal to, should be negative 8, is equal to negative 8. Now let's see if this one works. So we're going to do negative 8 control var x, enter. And we're going to do, it's actually really just this. Now it's positive. That's weird. What if it was positive 8? I don't think this is possible. You can't raise something to an even exponent and equal something negative. I think this is the empty set. Let's move on. Dumb question. Moving on. All right, this one's not bad. This is 3 to the x equals 3 to the negative 2, because this is 3 squared, but it's in the denominator, so it's negative, so x equals negative 2. It works. Sorry, I'm trying to move a little bit quicker. 25, 5 times 5, 25, 125. That's really 5 cubed, but it's in the denominator, so it's negative. So I get 5 to the x equals 5 to the negative 3, so x equals negative 3. All right. It's about to get crazy. The next page gets crazy. So this is 2 squared, 2x plus 1, equals 2 cubed, 2x. In other words, 4x plus 2 is equal to 6x. Subtract 4x, I get 2 equals 2x, or x equals 1. You can check it if you like, or you can just trust me. Oh, this isn't bad. So 9 is 3 squared, 3x plus 1. 27 is 3 cubed x plus 2. Notice I'm putting these in parentheses. All right, so now I just set the exponents equal each other, so I get 6x plus 1 equals 3x plus 6. This is not 6x plus 1, it's 6x plus 2, because you got to distribute. Subtract the 3x, I get 3x equals 6. Got to stop skipping steps. We're subtracting 2. So 4, or x equals 4/3. I'm glad I'm catching my mistakes. Normally I don't. Are they getting harder now? Okay. So this question here was a 6-point question on a Regents exam a few years ago, because there's a lot going on this problem. I think I only got like 2 or 3 of these, and then I just show you a few transitions and we're done. So let's see, how much time do I got? All right, I'll be back. All right, so we're going to do it the same way, but because I got cubics and squares, there's going to be some factoring involved. So I'm going to change this 16 to 2 to the 4th times x cubed plus 3x squared is equal to 2 cubed times 7x over 3. Now that the bases are the same, I can set the exponents equal each other. We'll do a little bit of work first. So this is 4x cubed plus 3, distribute the 4, almost did it again, plus 12x squared equals, now these 2's, remember we're getting rid of these, we're just setting the exponents equal to each other. If I multiply 3 over 1 times this, the 3's cancel, and I end up with 7x. Now, 7x. Now, if you didn't do that, you'd end up with 21x over 3, but that's just 7x. Since this is now a quadratic, I'm going to bring everything to the left side and factor, so I get 4x cubed plus 12x squared minus 7x equals 0. I can take out an x. That gives me a 0 as one of my answers. 4x squared plus 12x minus 7. Now you can either factor this, or if you have the TI Inspire, it will give you the solutions. Now you still have to show your work. You still have to tell me that your answers are x equals 0, x equals something, and x equals something. You still have to do the factoring. But if you have this calculator, one of the nice things is if you go menu 331, it will find the roots of a polynomial for you. So you click OK, and you just tell it what the numbers are. 4, 12, and negative 7. So 4, 12, negative 7. Click OK. It says, is that your polynomial? 4x squared plus 12x minus 7. Yes. Press enter. Oh, my 2 roots are negative 7 over 2 and 1/2. Well, this is the tricky part. I know I got to get 4, so the only way to get 4 is 2x and 2x. And I know I got to get 7. The only way to get to 7 is 7 and 1. Notice this is a negative, so this had to be a positive, and this had to be a negative. Maybe I'll put up a lesson on how to factor using that TI Inspire. If you don't see one soon, ask me about it, okay? All right, those are my 3 answers. I do need to check those. So I'm going to store 0 into x, 0, control var x. Checking the first one's always the pain. So 16 raised to the x cubed. Be careful to get out of exponent mode. Plus 3x squared. Plus 3x squared. Again, checking the first one's always a pain. It's 1. And then 8 raised to the control division 7x over 3. 1. Okay, that one worked. So 1's an answer. Or that one works. And my next answers are negative 7/2. So I'll do negative 7 divided by 2, control var x. enter. And then I don't want to retype these, so I just go up to here to the first one. I hit enter, enter, I get whatever that is. Since it matches, they're equal, doesn't matter. And then I got to check 1/2, so I'll do 0.5, it's easier. Control bar X, press enter, 1, 2, 3, 4, 5, 6, there it is. That. Check them both, and they're both the same. So there's my answers. 0, -7/2, and 1/2. 3 answers work. That was a 6-point question. Solve algebraically. So is this. It's another 6-point question. Similar kind of a question. So we're going to do 2 to the 2, 4, 8, 16, 32, 64, 2 to the 6th times 3x cubed minus 7x squared. By the way, you should try these on your own. You shouldn't be watching the performed monkey do them. This is 2 cubed, -20x over 3. All right, so on this one I get 18x cubed minus 42x squared equals, the 3's cancel again here, and I get -20. I think this is actually a problem I made up. Bring everything to the left side. I get 18x cubed minus 42x squared plus 20x equals 0. Take out the GCF, which I think in this case is just a 2x. And I'm left with 9x squared minus 21x plus 10 equals 0. If you want to cheat, your answer here is x equals 0. Anytime you take out of GCF of x equals 0 is one of your answers. And you're going to come up with 2 different answers here. So it's menu 3, 3, 1. It's quadratic. 9, -21, 9, -21, 10. Click OK. So my 2 answers are 2/3 and 5/3. 2/3 and 5/3. Well, this has to be 3x and 3x. This is a positive 2, so up here it's a -2. This is a positive 5, so up here it's a -5. That's the factoring. I'm not going to bother to check these. These all work. So 0, 2/3, and 5/3. I know they all work. We're done with these hard problems. All right, one last hard problem. Oh my gosh. Oh, this was another 6-point question on a Regents exam. So at some point, this was a 6-point question on a Regents exam. So let's see how it's done. First things first, I'm going to condense these. It's subtraction, so I'll condense them into a division. So log base, notice I put the base down here, of 4x cubed minus 18x plus 15 all over 4x equals 2. Now, if you've heard me before, it's all about that base, all about that base, So I'm going to write this my base. It's a binomial, that's okay. Leave it in parentheses. X plus 2 squared, these two things are going to switch sides, is equal to 4x cubed minus 18x plus 15. Now, as you can imagine, my dodo birds last year, or whenever this test was on there, decided to divide this out. You can't divide this out. This is not, remember, this is like big parentheses here. You can't divide that 4x and this. The only thing you can do is cross multiply. Now, before I cross multiply, let me convert this. Let me just double distribute on this left side. So I end up with x squared plus 4x plus 4 over 1 is equal to 4x. Remember, this is a 6-point question. There's a tremendous amount of work to be done on a 6-point question. You're not going to just do it in a couple of steps. You got things to do. All right, now I can cross multiply. So 4x cubed minus 18x plus 15 is equal to 4x cubed plus 16x squared plus 16x. The good news is the cubes cancel. That's the good news. The cubes are going to cancel. So there's my x squared. It's positive, so I'm going to bring everything to the right side. So I end up with 0 is equal to 16x cubed plus 34x, right? I'm going to add this 18x over here, minus 15. All right, this is a perfect example of cheating, if I've ever seen one. X equals 1634 negative 15. Menu 3, 3, 1. 16 34 negative 15. Negative 5 over 2 and 3/8. So this one was 2x plus 5. This one was 8x minus 3. The 8 goes out front, and it's this opposite sign. You do have to check these. I'm just going to tell you right now. Oh, man. Let me show you how to check these. These are a pain in the neck to check. So negative 5 divided by 2. And I also want to show you because this one's not going to work. So log base. Oh, I started next. So control var log base x plus 2. Again, the first one to check is always the pain. Of 4x cubed. 4x cubed. Get out of cube mode. Minus 18x plus 15. Minus control log x plus 2 of 4x. Now, if we're hoping that this equals 2, this one's going to crash, and it gives you this. So that means that answer didn't work. And the reason that answer didn't work is because that answer is really negative 2.5. And negative 2.5 makes these negative. It also makes this negative, which is a big problem. You can't have it. But the other one should work fine. What is the other one? 3/8. So we'll do 3/8. Now the cool thing is, once you've checked one, that's really all the work you have to do right there. And then I just press up, 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 up. Hit this. And by the way, if you don't get one of them to work, probably, notice how it's 2 and we want it to be 2. If you don't get one of them to work, you probably messed something up. I hope that's it. Oh my gosh, there's another one. All right, that's it. This is the last one of these. Let me come back. My delicious Dunkin' Donuts is cold. It's an hour and 12 minutes long. You're probably getting tired of this. I'm getting probably tired of this. Try this one on your own, though. I mean, this is a 6-point question. Lots of work here. See if you can do it. Go ahead, hit the pause button. No, really, hit the pause button. Oh, you're back. Oh, okay, cool. So, let's do purple. Oops, didn't select purple. Purple. All right. So what we're going to do is we're going to condense it. So it's log base x plus 6 of, now this is addition, so these two things are going to get multiplied. 2 minus 3x times 4 plus x equals 2. Now you got to convert it into an exponential. So it's all about that base, So x plus 6 squared, this goes over here. This comes over here with this. Equals 2 minus 3x times 4 plus x. Now we got a whole lot of double distributing to go. This is really x plus 6 times x plus 6. So this is x squared plus 12x plus 36 equals 8. And this is plus 2x and minus 12x, so that's minus 10x. And then minus 3x squared. You never want to work with an x squared that's negative, so everything's coming to the left side. Hopefully you can do this. I'm going to do it very quickly. I get 3x squared. Nope. We're going to add 3x squared. So I get 4x squared plus 22x plus 28 equals 0. Let's take out the 2. I'm left with 2x squared plus 11x plus 14 equals 0. Yes, I know. Nothing multiplies to 14 that adds up to 11. I'm not going to cheat on this one because it's easy factoring. This is just 2x and plus x and plus 7 and 2. So my two answers are x equals negative 7 over 2 and x equals negative 2. This was actually a much easier question than the last one. If you check these, and I'm not going to take the time to check them, you would find out that I think they both work. So they both work. All right. Now let's get to work. We're just going to quickly go through these. I want to convert log 12. Log 12, okay, so I can rewrite that as log of 2 times 6 or log of 3 times 4. But either way, it's multiplication. Multiplication turns into addition. I see 6. That can't be right because this would be log of 2 plus log of 6. That's all right. It's not subtraction. And we're not going to multiply. So it actually is this one. And the reason it's this one is because it's log base 3 plus log base 4. But they rewrote 4 to be 2 squared. And then the 2 slides out front. 4x, that's really log of 4 plus log of x. Remember, multiplication converts to addition. Ka-choom. So they just took the log of this side. So they're going to, really what we got to do is take the log of pi times r squared. Well, that's the log of pi times the log of r squared. Exponents come out front. Oh, plus. All right, so this is, we're going to take the log of this. It's division, so we're going to take the log of x squared over k. Division, when you expand it, turns into subtraction. So log of x squared minus log of k. 2 goes out front. You should pause now and try these suckers on your own. See how you do. So we're going to expand this, so that becomes the log of b cubed minus the log of a. Go forward. We're going to expand these, so this becomes the log of x minus the log of y squared. 2 goes forward. This is the log of x squared equals the log of 3a plus the log of 2a. All I did was bring that over. Now, if I've got multiplication here, that's really addition. So this becomes log of x squared equals the log of 6a squared. Oh my gosh, are they kidding? Want to know what log a equals? So this becomes the log of x squared. What is this? Oh, I want to know what log x is. Oh, man. I want to know what log x is. So really this 2 should have come out front here. So what I have here is log of x is equal to log of, let's put a 1/2 out front, because I'm dividing by 2. Log of 6 plus the log of a squared. This is 1/2 log of 6 plus 1/2. All right, I did a terrible job explaining this one. This is a really hard problem. I better do a better job explaining this one. First things first, this 2 is going to slide forward. So this becomes 2 log x equals, and then this is going to go to the other side, log of 3a plus the log of 2a. Now we're going to condense to the left side, the right side. This becomes the log of 6a squared. And then I'm going to divide by 2. So I get the log of x equals. So I'm going to split this up, but they each get the 2. So it's really like having a 1/2. So this is really the log of 6, but divided by 2, plus the log of a squared, but the square goes out front, divided by 2. Notice these cancel, and this is my answer. That's a really hard problem. All right, so you have to remember that exponent for a radical is really 1/2. So that 1/2 comes out front, log xy, but multiplication turns into addition, so this becomes 1/2 the log of x. Since the 1/2 goes to both, we're going to put it in parentheses, the log of y. Almost done. All right, so log of x. So we're going to take the log of this side. So this is the log of 8 squared times the square root of 5. So this becomes the log of 8 squared plus log of... Now square root is really a 1/2 exponent. So let's just do that right now because I'm sure there's a 1/2 over here. The exponents come out front. You get 2 log 8 plus 1/2 log 5. And I hope they didn't make it worse than that. There it is. So we've got subtraction. We're going to take the log of this side. We've got division. That's going to turn to subtraction. So this is the log of a b to the 1/2 because it's the square root minus the log of c. Now this is multiplication, so that'll turn into addition. So this is the log of a plus the log of b to the 1/2 minus the log of 6. The 1/2 floats out front, and my answer is choice 1. Again, this is division. It's going to turn into subtraction. So I get the log of xy to the 1/2 minus the log of z. So which one doesn't have a 1/2 with a z? Well, these two don't. So these two aren't right. So the 1/2 comes out front. So it's 1/2 the log of x plus the log of y minus the log of z. And this is the right answer. This is the exact same problem as this. So the answer is, I'm circled it. There it is, right there. This is the log of a over b to the 1/2. So it's really 1/2 the log of a over b. So division turns into subtraction. So this is 1/2 the log of a minus the log of b. What do we got? 2 left? Am I done? 2 left. So again, we've got division. So it's going to be subtraction. They're all subtraction. That's good. So this is the log of x to the n minus the log of y to the 1/2. The n goes out front. The 1/2 goes out front. And it's choice 1. 1 left. So this is the log of x squared y cubed minus the log of z to the 1/2. This is multiplication. It turns into addition. So this is the log of x squared plus the log of y cubed minus the log of z to the 1/2. Exponents slide out front. So this should be 2 log x, 3 log y, minus 1/2 log z. There's your answer. All right, kids, that's it. That's all she wrote. Holy crap, that was a long video. Catch you on the flip side. Logarithms out.